All right, let's get started. Good afternoon, folks, and welcome to Storage 303 breakout session, the deep dive on Glacier. My name is Mas Kubo. I'm a product manager for Amazon Glacier, and I'm proud to say I've been with AWS for almost 8 years now, years before Glacier even existed. And at that time, customers told us they really wanted a way to cost-effectively, they wanted a low-cost way to store their object storage for data that they didn't need millisecond access to. And so in August 2012, we launched Amazon Glacier, and it quickly became one of the most popular services because customers loved saving on their object storage. And over the last 5 years, it's been a really awesome journey watching Glacier grow into an exabyte scale service, supporting a broad spectrum of use cases from financial services, media and entertainment, public sector, healthcare and lifecycle, life sciences, and more. And as a show of hands, who uses Glacier today and is just here to learn some more about Glacier? Awesome, a lot of hands, that's great. Who uses S3 but wants to learn more about Glacier to, considering saving, all right, even more. Who has taped repositories today and that are considering using Glacier to replace? Awesome, a lot of hands. Who's here just to pass time until replay party? My hand's up for a reason. Me too. Cool. Well, regardless, you're all going to get something out of this session. But if there's one thing I want you to take away, it is that Glacier is a powerful archival service that can address the broad spectrum of archival use cases. Everything from your deep offline archives where you're taking advantage of Glacier's ultra low storage price, all the way to super active archives where everything from news broadcasting, content distribution, mass retranscoding, big batch workloads, et cetera, where you're taking advantage of Glacier's retrieval options to cost-effectively make use of your data. And let me apologize in advance. I managed to catch a cold this week. I don't normally sound like a frog, so please bear with me. So today we're going to cover a quick overview of AWS's storage portfolio. I'll then give an overview of Glacier's value proposition and then dive deep into the features, including the pricing and TCO, durability and security, data ingress, egress, a new feature launch. And then throughout the presentation, I'll be giving some pro tips on how to best leverage Glacier, as well as highlight some customer examples and the ways that customers are taking advantage of Glacier. So taking a look at storage in AWS, customers have taught us over the years to think of storage based on 3 key elements: file, object, and block. And oftentimes, multiple elements are necessary for a successful cloud strategy. Customers asked for file systems that work at a petabyte scale with consistent latencies, and we launched EFS, which gives a simple file interface for your EC2 instances that's highly scalable, highly performant. We've got S3 and Glacier, which are the object storage services that are the ultimate repository that are both highly durable and cost-effective for everything from cloud-native applications to big data workloads. And then finally, EBS is our block storage. It offers the lowest latency in our portfolio with provisioned IOPS and general-purpose SSD volume types for high IOPS and low latencies, as well as the low-cost throughput optimized storage volumes to lower the cost of using persistent block storage for your EC2 instances. And EBS supports a broad range of workloads, everything from transactional databases to NoSQL databases and data warehousing. Surrounding our cloud storage portfolio are a variety of means to move data in and out of the cloud that best suit the value, time, and workflow demands of those data transfers. Everything from the Snow Family that make large-scale, petabyte, even exabyte data transfer from your data center to AWS, Storage Gateway that gives you a seamless and secure connection between your on-premise environment and AWS, Direct Connect, which gives you a dedicated, secure, high-speed network connection to AWS. S3 Transfer Acceleration, which leverages our edge infrastructure and optimized network protocols to accelerate the data transfer speeds up to 500% higher than the general public internet. Kinesis, which offers real-time analytics of streamed data with built-in BI tools and dashboards, and also our third-party storage partners that integrate with our services. And finally, our cloud storage services integrate with our data security and data management features and services that we offer. Everything from automated data classification with Amazon Macie, business analytics via AWS QuickSight, serverless computing with Lambda, and all the auditing, monitoring, and security features provided by CloudTrail, CloudWatch, IAM, and KMS. Looking more closely at S3 and Glacier, S3 and Glacier provide unmatched durability, availability, and scalability. And I'll go into more detail in a later slide, but S3 and Glacier were built from the ground up to deliver a customer promise of 11 nines of durability. Data is automatically distributed across a minimum of 3 physical facilities that are geographically separated, typically by miles. To quote Gartner, Amazon S3 is the largest public cloud-based object storage service as measured by data under management. AWS has more insights than any other vendor on how customers use public cloud storage services at scale. And this is why customers like Adobe, Uber, Netflix, they're working with tens of billions of objects spanning petabytes of data to deliver deeper insights and better solutions for their customers. Next is security and compliance. S3 and Glacier have the most comprehensive security and compliance capabilities. S3 is the only cloud storage platform that supports 3 different types of encryption. You can choose between automated server-side encryption, encryption with KMS managed keys through the KMS service, and encryption with keys managed by you. Glacier offers integration with CloudTrail as well to show your logs and monitoring and retain all the storage API call activities for auditing purposes. S3 is the only cloud storage platform that includes Amazon Macie, a service that uses machine learning to automatically discover, classify, and protect sensitive data in AWS. S3 and Glacier supports more security standards and compliance certifications than any other offering. Everything from PCI, HIPAA, FedRAMP, SEC Rule 17-A, EU Data Protection Directive, FISMA, what have you, helping to satisfy all the compliance requirements that you might face. This level of protection is what helps highly regulated organizations like Capital One and the United States federal government to operate more securely in the AWS cloud than they would in their own data center. Query in place. We just announced yesterday during Andy's keynote S3 and Glacier Select, which allows you to run queries on your data at rest. S3 and Glacier is the only cloud storage platform that lets customers run sophisticated analytics on their data without requiring them to extract and move that data to a separate analytics database. And so now anyone who knows SQL can use Amazon Athena to analyze vast amounts of unstructured data in S3 on demand. Flexible management. So S3 and Glacier offer the most flexible set of storage management and administrative capabilities. If you're a storage administrator, you can classify, report, and visualize your data usage trends to reduce cost or improve service levels. Objects can be tagged and customized with unique customizable metadata so that you can see and control your storage consumption, cost, and security separately for each of your workloads. The S3 inventory tool is a great way to, it provides scheduled reports about your objects and their metadata for maintenance, compliance, and analytics operations. And finally, S3 can also analyze object access patterns to build lifecycle policies, and I'll go into more detail later, to automate the lifecycling of your data across the various storage classes. And finally, S3 also works with AWS Lambda. You can log activities, define alerts, and invoke workflows, all without managing any additional infrastructure. And last but not least, we are the most supported platform with the largest ecosystem. In addition to integrating with most AWS services, S3 and Glacier's ecosystem include tens of thousands of consulting, systems integrator, and ISV partners. And our marketplace is filled with over 3,500 software listings and 1,100 independent software vendors that are pre-configured to deploy on S3 and Glacier. And so you can easily use S3 and Glacier with the popular backup, DR, primary storage vendors that you may already know and love today. Whether you are an individual developer, a startup, or a multinational enterprise, within minutes of setting up your AWS account, you gain access to AWS's global infrastructure with 16 geographic regions around the world, totaling 44 availability zones, with an additional 6 regions and 17 availability zones announced to be launched, including Bahrain, China, France, Hong Kong, Sweden, and a second US government location as well. Startups love knowing that as their business grows and as they hope to grow very quickly, they can scale up on AWS and scale across the globe. And of course, enterprises love that we can already support their global operations from day one. Also, many Glacier customers in particular who require geographic redundancy leverage our global availability to make it easy to achieve that regional redundancy. As I mentioned, a lot of customers with well-known brands are leveraging Glacier today. These are just to name a few who are all running multi-petabyte workloads on Glacier. So at AWS, I love solving problems for customers, removing hurdles. I've yet to meet a customer who enjoys, much less is in the business of, dealing with media handling, complex technology refreshes, mass migrations, capacity planning, et cetera. These are all undifferentiated heavy lifting that your business should not be wasting precious resources on, time and resources. Glacier solves this for you and allows you to focus on solving the problems for your end customer or for your organization. So now I'm going to dive into Glacier's features. I've categorized these into 3 overarching sections: cost optimization, durability, and security, and data ingress and egress. So let's start with cost optimization. Glacier's #1 feature is ultra-low pricing. Glacier is nothing if not a way to store more data for less. Amazon Glacier starts at just 0.4 cents per gigabyte. But it can be hard to fully appreciate the economics of Glacier when you're looking at all these decimal points with the pricing and whatnot. So let's take a look at a petabyte. A petabyte on S3 is just over $22,000 a month, which is an incredible price for what is widely considered the gold standard for cloud object storage, or just over $13,000 for S3IA. On Glacier, that petabyte is just $4,200 a month. So as your data scales, the dollars really add up when it comes to the savings. So looking at a petabyte, you're saving tens of thousands of dollars a month for data that can be stored in Glacier. Furthermore, at Glacier, we work relentlessly to innovate on everything from our software and processes to our data center infrastructure and operations to drive our costs out and in true Amazonian fashion, pass on those savings onto our customers, onto you guys in the form of price drops. When Amazon launched in August 2012, we launched with a price of 1 cent per gigabyte, which at the time was a revolutionary price. Since then, we've dropped our price by 30% to 0.7 cents per gigabyte in 2015, and then again by 43% just last year down to 0.4 cents per gigabyte. This equates to a historical annual price decrease of 19%. And we have, the Glacier team is super focused on cost optimization, and we have no plans to stop driving the cost of archival storage down to the ground. And one customer case study that I'd like to highlight related to TCO is Sony. Sony was dealing with complex, expensive, and an aging legacy tape hardware system. They were holding 2 copies of data on tape in 2 geographically separated locations. They wanted to lower their time to market to offer their media content to their end users. They wanted to have a durable storage solution that was going to be scalable. And they moved a 25 petabyte workload onto AWS, which is quickly growing to 40 petabytes. They store massive amounts of media content in Glacier, and they access hundreds of terabytes of data and on a continuous basis to deliver their content to their customers. I love this story, this customer case study, because they wanted more durability, more flexibility, better performance, better time to market, and they wanted to lower their cost. And they were able to achieve that with Glacier. They loved their 2 copies of tape, but when they understood the durability model of Glacier, as well as after we released the new flexible retrieval options just last year, which I'll go into more detail later, they quickly realized that Glacier was a superior solution than this legacy tape hardware system that they were maintaining. And in particular, they did a very deep TCO analysis that included all the cost of migration. You could see their cost jumping at year 5 along that blue line, which is when they were having to scale out a new tape solution, and compared that to that smooth cost line that's growing as their data grows along that orange Glacier line. And all that green is the savings underneath that all equated to over $10 million in savings over 7 years. So to help make it easier to get your data into Glacier, you can write lifecycle policies that move objects automatically from either S3 standard or S3IA into Glacier based on the age of that object. Policies are set at the bucket level, but you can also filter that policy, based on a prefix or based on tags. This is an example of moving. For example, you can define a policy that moves all objects older than 30 days to S3IA, and then anything older than 90 days to Amazon Glacier. Here we go. We're going to do a demo. It's super easy to set up a lifecycle policy, and in fact, I'm going to set one up after I turn my computer on. All right, let's give this a try. Boom, here we go. So I'm here in the S3 console. Under the Management tab, you'll see the option for a lifecycle rule. I'm going to add a lifecycle rule here. I'll give it a little name. You can add the prefix or the tag filter to this rule. Here you can set separate policies for your current version and your previous version if you have S3 versioning on for that particular bucket. I'm just going to create a lifecycle rule for current versions. Add a transition to Amazon Glacier after, let's say, 90 days. Next. Configure. So the first policy was for when to move the object from S3 to Glacier. This next policy, which is optional, is to expire or automatically delete the object after a given number of days. So let's do this after, let's say, 365 days. The quick review, looks good, done. And so now we have a rule that will automatically transition my massive bucket of 2 objects into Glacier automatically. And that's all it takes. So super easy, and that will automatically move your data to Glacier. But How do you know which objects should go into Glacier? I mean, you don't have millisecond access to that. There's retrieval costs associated with that. So we've come out with some features that help you to strategize around this. But first, let me back up for a second. You want to think about your workloads and classify them. You've got your hot data that's active, or maybe it's temporary, it's short-lived, you're accessing it very frequently. S3 is great for that. It's 2.1 cents per gigabyte. S3IA is more for your warm data. It's less frequently accessed. There's a retrieval charge of 1 cent per gigabyte, but the storage cost is almost half of S3 standard. And then finally, you've got Glacier with, that's really for your cold data. This is your archive, your compliance data, data that you're accessing less frequently. You don't need millisecond access to it. It's 0.4 cents per gigabyte, and there's various retrieval options, but they start at a quarter of a cent per gigabyte to retrieve that data. One thing I wanted to emphasize here is that as you're moving along these storage classes, you're maintaining the 11 nines of durability, the scalability, the query in place features, the global availability. All right, those are all features and value propositions that you can rely on as you're moving across these storage classes. So, first pro tip, how to choose a storage class. Specifically in this case, moving from standard to S3IA. Number one question, access frequency. How frequently are you accessing the data? You don't want to access data moved to S3IA more frequently than once a month in order for it to be financially beneficial. And then secondly, that data should be stored for longer than 1 month. There's a 30-day minimum storage period for data in S3IA. Now, this can be, you want to think of it on an average basis across a large data set. You're obviously not going to go object by object and decide what your access patterns and retention are. But as long as, for a given data set, on average, you're accessing this data less than once a month and retaining it for at least 30 days, you're going to be better off with S3IA. This is the TCO example is just a quick example of a 1 gigabyte object that's stored for a year and accessed every other month, achieving a savings of 17% over a standard. Now, what if you don't want to do this all by do this yourself? Well, last year, actually, I don't remember when we launched this, but we launched storage class analysis, which automates that exact exercise that I just went through with you guys. It gives you a daily storage class analysis of the access patterns for your data based on the age. And just to give you an idea of what this looks like, it'll give you a console view here that'll show as data ages, the access frequencies. So the blue bar metrics here are your storage, and the purple is the retrieves. So you're retrieving more than you're retrieving objects multiple times a month, and eventually, once you hit 90 days, I think I have a red thing here. You probably can't see that. In this example, as data reaches 90 days, the retrieval patterns drop off a cliff, making it a good use case for S3IA. So you would, in this case, write a policy that transitions data from standard to S3IA once it's 90 days old. So super easy to use, automated, and gives you confidence that you're writing the right lifecycle policy to minimize your storage costs. Pro tip number 2, a lot of customers say, hey, lifecycle policies are great, but they apply to the entire bucket. Sure, I can filter on a prefix or a tag, but what if I just want to move one particular object to Glacier? The lifecycle policies, require it to be a certain age and match a certain filter, et cetera. I want just this one object to be moved to Glacier today. Today, we don't have an API call for that. However, there's a way to achieve this effectively through the tagging feature. You write a 0-day lifecycle policy where any object that matches that filter for that policy is moved to Glacier on that day. And you can add a tag filter to that policy so that when you tag an object with that tag, it is then moved on that day to Glacier. And so that's a way to achieve an object-by-object transition to Glacier via an API call. Okay, next. When should data be moved to Glacier? So the S3 Analytics feature is all about the trade-off between standard and S3IA. But when it comes to Glacier, there's a couple things, additional things that you need to keep in mind. The number one question is, do you need millisecond access to your data? If yes, Glacier's not a good fit. Glacier offers 3 different access retrieval options, the fastest being on expedited with 1 to 5 minutes. Standard is 3 to 5 hours, and bulk is 5 to 12 hours. Glacier has a 90-day minimum, so objects you'll want objects that live longer than 3 months is a good rule of thumb. Well, is a good rule of thumb for moving data to Glacier. And then depending on which retrieval options you expect to use for your data, as a rule of thumb, if you're using expedited, you want to be accessing data on average less than 3 times a year. For standard, less than once a month. And for bulk, less than 4 times per month. And that's the trade-off between the retrieval cost and the savings that you get on the storage. And the TCO example is a similar one to the standard and S3IA one, where the savings ranging from 7% to 73% compared to S3 or S3IA. But the big question, again, just to reiterate, is do you need millisecond access time? And how frequently are you accessing it? One more pro tip in this section is to target average object sizes that are at least 1 megabyte. And this is really around, again, cost optimization, minimizing your storage cost. Glacier charges a 32 kilobyte overhead for every object, regardless of its size. So for example, if your average object size is 32 kilobytes, you're effectively paying twice for that storage. So you want your data to be targeted 1 megabyte. It's not a strict rule, but just as a general rule of thumb. And then also you want that data to be long-lived. And it's a related point, but in addition to the 32 kilobyte overhead, there's also a put request price of 5 cents per 1,000 objects. And so you can think of that as like an upfront cost that you would want to amortize over a longer period of time and over a larger amount of data, i.e. the object size. So these are just 2 rules of thumb when you're thinking about what data to move to Glacier. All right, moving on to the next section, durability and security. I want to talk a lot about the durability model so that it's clear what the value proposition is for S3 and Glacier. So let's return to traditional redundancy model. You've got your one data center. Maybe you're running some RAID, some periodic fixity check. But you've got no geographic redundancy. You're vulnerable to concurrent failures and catastrophic events. We worked with a major Hollywood media company to run the same Markov model that we use to calculate the 11 nines of durability. They used that to calculate what the equivalent number of nines would be for a single copy of tape in one location, and they came to about 4 to 5 nines of durability. So you're sitting here, you're not comfortable with this, and so what do? You double the cost and the effort. You build a DR site that's maybe in a different geographic location. Maybe it's just across the street, which is a pretty minimal geographic redundancy. But now you're doubling the cost and the effort. It may not be synchronously redundant. And of course, you're dealing with all the migration and the technology refresh doubled as well. And this, again, this large Hollywood customer calculated the number of nines when having 2 copies and geographically separated to be roughly 5 to 6 nines of durability. Let's imagine a world where where you don't just have one location, not just a secondary location, but 3 geographically separated locations that are miles apart. It's not asynchronously, but synchronously stored in these 3 different locations. Not only do you have 3 different data centers, you actually have multiple data facilities in each of these geographic areas, each with their own separated power, network, flood domains, with automatic periodic data integrity checks, it's tolerant for concurrent failures across things like disks, and nodes, racks, networks, and WAN providers, et cetera, with the option to also duplicate this entire model to yet another entire geographic region. If only there was an API for this. If this sounds familiar, that's because it's Glacier and S3. This is the durability model of 11 nines of durability, and this comes built into the storage price and is there to protect your important data. So I'm hoping that illustration gives you a better idea of what 11 nines of durability means, which can just sound like a number to most. If you haven't already, check out James Hamilton's video. You can search for 1026, which was the session number at the time, where he goes into great detail about our architecture and how we achieve this. Glacier has a lot of built-in security features. We have all data in Glacier is encrypted at rest by default. Regardless of whether you send it to us with encryption keys yourself, we will re-encrypt it by default at rest. We also offer server-side encryption, which I've mentioned, vault access policies, which makes it easier to set access policies on a vault or a bucket, if you will, which can be easier than doing it at the user level. And of course, CloudTrail integration, which I mentioned, and then Vault Lock, which is a really strong compliance control that lets you achieve worm and meet some of the stricter compliance regimes like SEC Rule 17-8. And it is easy to set up, and so I'm going to do another demo here. Just bear with me. Let me switch screens so that at least you can see some pretty snow while I do this. I apparently did not give enough offerings to the demo gods this morning. They are very upset. Okay, I'm not doing a Vault Lock demo. I might return to that later, but my computer is not unlocking. Okay, so let's just move on. One case study that I want to highlight, the proof point is a leading security and compliance company that provides cloud-based solutions for threat protection, incident response, secure communications from social media and mobile security, and they help their end users protect from phishing and malware, spam, meet compliance requirements, et cetera, and they are big users of Vault Lock to achieve both worm. They have to meet financial services, the SEC rule, as well as healthcare and patient records, et cetera. And they are a great use case for utilizing these compliance controls that we offer on Glacier. Okay, so it's great to have durability. It's great to have low-cost way to store your data, but it needs to be easy to get that data into Glacier, and possibly more importantly, to be able to get to your data. So I want to spend some time focusing on that. And as I mentioned in our portfolio slide here, we've got a long list of services and features that make it easy to get your data in and out, including the Snow Family. So we've got everything from Snowball to Snowball Edge and Snowmobile that has up to 100 petabyte capacity. Snowball starts at just $200 per job, and it has S3 compatible endpoint, making it really easy to move your data into the Snowball device and to have it then sucked right into your S3 bucket in AWS. This is a great way to not only bypass any necessary network upgrades that you might need to do to move large amounts of data into the cloud, but it's also secure, and it can also be a faster way depending on your network availability. Some customers are in remote locations. Some customers have already, are already using all of their network bandwidth at their data center and want to avoid a lot of the upfront costs associated with upgrading your network capacity. So this is a great way to migrate data into the cloud. Last year, we launched Snowball Edge, which has 100 terabyte local storage and allows for local compute equivalent to an M4 4 extra large. You can run Lambda, and we have multiple interfaces, and this also allows for an NFS endpoint. So there's more of a seamless integration with your on-prem environment to be able to get your data into the edge and then eventually into the cloud. Scripps Networks is a leading developer of lifestyle content on TV and the internet. They own the brands like HGTV, Food Network, Travel Channel, et cetera. They needed a storage platform to manage their active archive content, and they had an existing content repository that was really large, and they faced network capacity constraints, and they used Snowball to move massive amounts of data quickly and securely into Glacier, and are now operating that workflow out of AWS. Storage Gateway. This enables you to use standard storage protocols, including an NFS file gateway, iSCSI, as well as VTL. The VTL gateway is compatible and integrates with virtually every backup appliance, making it super easy for you to move your tape libraries into AWS using the same storage management tools that you already use today. And then finally, we integrate with a wide range of storage wide range of storage partners, everything from archive, backup and recovery, business continuity and DR, and primary storage. And you can see a list of very popular storage partners listed there. Multi-part upload. So if you have large archives that you're trying to get into AWS, and you want a more reliable throughput and item potency of getting those large objects in, consider using multi-part upload. Very easy to use, 3-step process. You start with an initiate upload call. You then upload each of those individual parts and then complete the multi-part upload. This is a great way to get consistent throughput and a reliable way to get large objects into the cloud. I'm going to quickly switch back over to my laptop that I now have unlocked to show you how to set up a vault lock policy. So I'm here in the Glacier console, and I have a vault here where I'm going to set up a vault lock policy. Let's delete this because I already created it. All right, so here I'm going to initiate a vault lock policy. You add a permission, and in this case, I'm going to do deny everybody from deleting an archive with the condition of numeric value greater than, less than archive age and days 365. So what this means is don't allow anybody to delete an archive that is less than 365 days old. I'm going to add this condition, which is now set down here, and we're going to say add permission, and then initiate vault lock. The vault lock is a 2-step process. You're going to define the policy. It's going to create a temporary it's going to temporarily activate that policy on the vault for 24 hours, and then will automatically be removed. The reason for that is because once completed with the second step, it can no longer be removed, even by the root user. And this is to meet certain compliance requirements. And so we give you a kind of a 2-step confirmation process. You have to copy this lock ID. This is the temporary policy, and if you want to complete the vault lock, then you need to put in that lock ID and then complete it. Acknowledge that even the root user won't be able to remove it, and then complete it. I'm not going to complete that one on my account. I don't want to keep this data for 365 days. All right. So super easy, takes less than a minute, but be thoughtful about it. The 24 hours is to allow you to test that the policy is does what you want it to do. You can specify certain users that are exceptions to the rule, et cetera. This is also a way to enable legal hold on your vaults as well. Okay, so switching back. And moving along. When we first launched Glacier, we gave customers just the standard current model of getting your data in 3 to 5 hours. But we heard from customers that they occasionally need quick access to their data. And they also wanted an option to get large amounts of data out inexpensively. And so last year, we launched expedited retrievals and bulk retrievals to give customers this flexible options for getting at your data. Glacier is a great place to store your archives very cheaply, but it is also, you are also able to use it for active archive use cases. And that's really what these new retrieval options are designed for. And the one thing that I want to make sure is clear is that these are not storage classes. You do not need to choose which retrieval tier you're going to be using when you're uploading data into Glacier. You can use any of these retrieval options on any of your Glacier data. And so with these retrieval options, Glacier is really addressing everything from the on-site tape replacement to the off-site tape replacement use cases. And I'm going to do yet one more demo where I will retrieve an object that is in Glacier during the course of this presentation to show you how fast the expedited retrieval is. I've come back to the S3 console. I've got my 2-object bucket. I'm going to grab this guy, bar, and we're going to, under More, initiate a restore. Here, you're going to specify how long you want that copy to be restored. When you have data in transition to Glacier storage class from S3, when you restore that data, it's a temporary copy. If you want to have a permanent copy out of Glacier, you need to then copy that temporary copy to a location to become its own object, at which point you can keep it until it's deleted. So here you're specifying how many days you want this temporary copy to be kept, after which it'll be automatically cleaned up for you. So I'm just going to put 2 days here. Here you select which option you want. I'm going to choose expedited so that we can get it during this session. And I'm going to hit restore. Having initiated that restore, you'll see here in the description for that object that the restoration is in progress. All right? So now I'm going to let that percolate while I move on to the presentation, and we'll return in just a couple minutes. Okay. FINRA is a great customer case study that I want to highlight. They quickly ingest lots of financial record data from many different sources and they wanted to store it in one location that they can, that's both durable and allows them to get at that data for either quick analysis, for which they use expedited retrievals, as well as bulk retrievals for doing mass batch processes to run analytics on those financial transactions. And so they use bulk retrieval to restore hundreds of terabytes of data that they then suck into EMR to do these batch retrievals. And so this is a great use case of utilizing the 3 retrieval options while taking advantage of the low storage price of Glacier. And they estimate the savings of $10 to $20 million a year over their previous on-premises solution. So I wanted to go deep into the retrieval performance. I got a lot of questions about the retrieval options beyond just the price and the access times after we launched it last year, so I wanted to take some time to go into a bit of detail. For expedited retrievals, which again is going to give you your data in 1 to 5 minutes, I almost forgot. Let me come back to my expedited retrieval. Let's take a look. Crossing my fingers here. Okay, so this is now restored. It is restored until December 2nd, and if I hit download, you will see that it is being downloaded. That data was in Glacier. It is now on my laptop with an expedited retrieval. Super easy, super fast, super reliable. Coming back to expedited retrievals, the 1 to 5 minute access time is for objects up to 250 megabytes, beyond which it can take longer. As a rule of thumb, you can assume a linear performance there, but that would be a minimum. I often see like 1 gigabyte objects being restored in less than 10 minutes. Again, this is really meant for your occasional use, urgent access. It's also available the vast majority of the time, similar to Amazon EC2 instances, on-demand instances. So if you need guaranteed availability of expedited retrievals, I suggest using provision capacity units, for which I will go into detail in just a minute. For standard retrievals, which gives you your data in 3 to 5 hours, I have customers that regularly retrieve multi-terabyte objects in under 5 hours. So there's virtually no limit to the access time on standard. And for bulk, it's used today to, as I mentioned with FINRA, cost-effectively restore hundreds of terabytes of data in less than 12 hours. And it also is designed to support petabyte-scale workloads. Now, if you have a petabyte-scale workload, if you need to restore a petabyte quickly, reach out to your account team, talk to the Glacier team. It is a large workload that we would love to talk to you about, and we have some tools and scripts to help spread those requests out over time to get the most out of bulk retrievals. And one thing you want to keep in mind is that you're probably restoring that data to be either processed or used. You're going to make sure that the rate at which you're restoring data from Glacier back into S3 can then be processed at that speed with whatever it is that you're using. So for provision capacity units, a provision capacity unit ensures that you will get 3 expedited requests every 5 minutes and up to 150 megabytes per second of aggregate throughput across multiple requests. It's $100 a month per unit, which is very inexpensive, and there's no change required to your restore request. So if you purchase a provision capacity unit, simply make your expedited request and it will automatically be run through your provision capacity. One thing to clarify is that it does not accelerate your expedited retrievals. It just guarantees that you will be able to get 3 successful expedited requests every 5 minutes. Because again, expedited requests are available most of the time, like EC2 on-demand instances. So you're going to get the same access time of 1 to 5 minutes, even if you have provision capacity units. You can purchase multiple in order to get the performance requirements that you have. Now, I get a lot of comments. Glacier's great, low storage costs, but it's going to cost me a ton to get that data out. So I want to run through a few TCO examples of what that might look like to reassure you. So let's look at just the storage. Extremely cold archive use case. You're never doing any access. All you're paying every month is the storage bill of $21,000 a month. This is for a 5 petabyte data set. Okay? So no retrieval costs. We're all hunky-dory. Let's say now you have a cold archive store. Maybe it's a research archive or a log repository, and every once in a while you're retrieving your data. And let's say your average object size is about 100 megabytes, and let's assume that over a course of a month, you're restoring 180,000 objects using standard retrievals, which equates to roughly 50 terabytes or 5% of your data. Sounds like a lot, probably going to be expensive. $533 or 2% of your total Glacier cost. Okay, that's retrieving 5% of your data, which, you know, if it's an archive use case, typically it's in this smaller range. I don't have a lot of customers retrieving 5% of their data. They do exist, but the point is the retrieval costs are very small. But what if you have more active use cases? Let's say you're doing mass transcoding, you're doing mass content distribution, like Sony. You can retrieve 20% of your data across 3.5 million bulk requests, and still your retrieval costs are only going to be 11% of your total monthly bill. All right? Glacier is not only a great place to lower and minimize your store costs, you can get to your data and do what you need to with it for a low cost. But let's look at an extreme case of a 5 petabyte workload, 100 megabyte average object size. You're doing the 5% of your data on standard requests. You also have 2 provision capacity units. You're making 10,000 expedited requests worth 3 terabytes of data, and the 2.6 million bulk requests, 750 terabytes, 15%. You're retrieving over 20% of your data every month. Still, only 19% of your total bill, and you're still going to be lower cost overall compared to storing it on S3 or S3IA, assuming that the access times are okay for you. So I just wanted to go over these TCO examples to show that the new retrieval tiers and the pricing really allows you to not only take advantage of Glacier's storage price, but also accessing and leverage the data that you have inexpensively. And finally, I've got 10 minutes left, and I really want to go through Glacier Select, and I also want to open it up to Q&A for any questions you guys might have, so I'm going to breeze through this a little bit quickly. But yesterday we launched Glacier Select. The Glacier team is super excited about this, because until Glacier Select existed, you had to retrieve your data, pull it into EMR or EC2 or what have you to filter through. With Glacier Select, you can run queries directly on your Glacier objects without having to retrieve them. It uses simple SQL expressions like select and where. Works just like a GET request, similar to a GET request, and it integrates with our SDK and the CLI. It's great for pattern matching, auditing, big data integration, and an example request, it works a lot like a restore request, except that you include the select expression inside of it. So just to run through this example really quickly, you've got a restore request where you're specifying that it's a select request. You choose which restore option. So again, it leverages the Glacier retrieval options of expedited, standard, and bulk, and it'll run that SQL expression in the time frame that you specify based on that tier. You can add a description, and then you specify the select parameters. Your input serialization, so if your object has headers, then you can specify that. Then you specify the expression, so in this case, select star. So it's just grabbing everything from the object. And then the output serialization. And then finally, you can specify what the prefix is of the object that will be created, that will be the output of that SQL statement, as well as access control and user metadata. Here are some more examples of what the select expressions can be. Everything from select star to, you can also specify column positional headers. Or if you have name headers, you can also specify those, and then of course use a where filter. So in that second example, it's grabbing 1 and 2 where 3 is greater than 100, right? So this is really great. So instead of having to pull the entire object out of Glacier, you're able to just grab a portion of the object that you have in Glacier. The way it works is you'll send that request, the initiate job, with the parameters that I just mentioned. We'll give you 200 OK to let you know that we got it. We'll then go and process that request. When we're done, we'll write it to your S3 bucket with the prefix that you mentioned, and give you a notification that that's complete. Very simple. Keep in mind with the pricing for this. So again, you have different pricing whether you use expedited, standard, or bulk. And there's several pricing dimensions. You've got the data scanned, which is the the size of the object that we are scanning and running the SQL statement on, and that's 2 cents per gigabyte for expedited. The data returned, which is whatever data is returned based on how you define your SQL expression, that's 3 cents per gigabyte, which aligns with the data retrieval price on Glacier, and then also 1 cent per request for expedited. And that concludes my presentation. Thank you for listening. I'm going to move to Q&A in just a second. Just a couple quick call-outs. If you want to learn more about storage, please visit Storage 312 at 3:15, where we're going to talk about best practices for building a data lake in S3 and Glacier. And also, you can now use these sessions to make progress in the certifications, the AWS Certification Solutions Architect and the AWS Certified SysOps Administrator certifications. So check those out. And finally, Q&A. If you guys have any questions, we have microphones set up on either aisle, and I'd be happy to use the last 5 minutes for questions. Sure. Oh, thank you. Thank you. Go ahead.
Could you share some more information on a fixity check? What exactly has been done and how frequently to ensure data integrity?
So I can't talk too much in detail, but what I can say is that we periodically scan through all of our data in Glacier and proactively find any potential errors and then restore those to the original hash. Okay. And that's all the information that I can give.
Okay. And then one more, if I can. The recovered data from Glacier, what storage class has it been restored to while it's available for a few days?
The reduced redundancy storage. In every region where reduced redundancy storage class exists, some of the new regions don't support that storage class because we're slowly phasing that one out.
Yeah, because last time I checked, the reduced redundancy was even more expensive than S3. It was.
That's true, but we are defaulting to the lowest priced storage class when it's being restored.
Thanks.
Is there any way to set a policy for archival on a prefix instead of the entire bucket?
Yes, you can filter on prefix as well as tags.
Okay.
Anybody else? Sorry, just one quick one on the mic over here.
Yeah, can this be CFT driven?
Say that again?
Can this be CFT driven?
I'm not sure what CFT is.
CloudFormation template driven.
So there are some CloudFormation templates that are being used to automate certain operations within object storage. So take a look at CloudFormation. You'll find some there related to S3 and Glacier.
Okay, thank you.
Yes.
As you run this Glacier Select and you run the query, then suddenly you realize that you have basically put in the wrong criteria, right? And then you realize it, and then you go back and fix it, or what are the options over there?
So that is not an option today. You'll just have to redo it. You can't cancel it, so to speak. But that is something that we're looking into as we get a lot more customer active use cases on Glacier, and customers are retrieving data all the time, and they're running into these cases where they made a mistake, or they didn't, or they retrieve it in bulk retrieval, but they actually need it faster, this kind of thing. But once you've initiated that time frame, then it can't be canceled. So that's something that we're looking into to be able to overwrite that job. And so if you have specific requirements, I'd love to hear more about it.
Okay, thank you.
We're using S3 as our primary storage and considering Glacier as a DR system. It would be really, so the only time we would be restoring from Glacier would be in a disaster recovery scenario. It would be really convenient if we could promote a Glacier object to a permanent S3 object rather than a temporary one that we need a second step to persist that.
Totally hear you. It's on our roadmap. We hear that one a lot.
Any timing on that?
I do not have official timing on that.
Thanks.
How can Glacier Select be used with Athena or with Spectrum?
We will be releasing integration with Athena in Q1, and you'll see details on how that integrates with Glacier. But we will
It will
support
work
that.
like Glacier and S3 both will work in a similar manner, right?
Correct. But when the objects are in the Glacier storage class, you can expect you have to incorporate the restore time in terms of the performance. But yes. Anybody else?
You alluded to at the beginning the analytics components.
Mm-hmm.
Where would the next place to probably do some more research to figure that out?
So take a look at the S3 and Glacier Select, which is a great way to do some analytics without having to retrieve it. And then beyond that, kind of depending on your use case, you're going to be using things like CloudTrail that are going to give you logs of any API activity. You're going to have S3 storage class analytics, which is going to give you the automated reports on access patterns for your objects. Those would be my top three suggestions for looking at that.
Thank you for the presentation. Quick question, I think you talked about what do you call it, 0-day transition from S3 to Glacier. For that, do we still pay for the price of S3 or only the Glacier price?
That's a good question. So for the 0-day, there is a potential short period of time after you've initiated that 0-day policy where you'll be paying for S3 rates until we get around to that object and move it. It will be moved within that day, but there will be a short window within that day where you'll be charged S3 pricing. But keep in mind, it's a fraction of a day, which is a fraction of a month. So it's going to be fairly minimal.
And then one last question. Is there a way to directly feed data into Glacier, or it does always go through S3?
So there is a way to get directly into Glacier via Glacier's APIs, which is a separate API set from S3. Depending on which door you go through, you have to stay within that door, so they kind of live in two different worlds, and there's a couple different feature sets, and so that you want to be mindful of. But there is a way. So if you go to Glacier's product page and you look through the APIs, you'll see the APIs there that'll give you details on that. But we are also looking into giving customers a way to go straight to Glacier while still being within the S3 world, if you will. Cool. Well, if that's it, we are out of time. And enjoy replay. Thanks, everybody.